Hey all. So let's talk reaction stoichiometry. So it's basically the same as any stoichiometry we've talked about. The only difference is now we're looking at dilution things. Okay, so it's still a reaction. The only or precipitation things. The only difference is we're using liquids, right? So we're looking at solution reaction stoichiometry. And so the big idea here is molarity is moles per liter, right? So because we have this idea that we can go from grams to moles to moles, all that jazz, anytime moles is involved, we can always do stoichiometry. So the big thing here is mole equals, or molarity, which is big M, equals moles per liter. Remember, your volume is in liters, okay? So here's what this looks like. So this right here, we've seen before, right? Going from moles of something to moles of the other thing. The new thing here is the volume. So I can give you volume and concentration of a solution and ask you to figure out, hey, moles of a different solution, because we know that big M equals moles per liter. This is not the same as making a dilution, right? So M1V1 equals M2V2, very different. This has to have a chemical reaction in place, okay? So for example, what volume of a 0.15 molar potassium chloride solution will completely react with 0.15 liters of a 0.175 solution? Here are the reasons I know this is not a dilution. It's reacting. I have two different things, okay? So for making a solution, I'm only making the one thing. It's just the one thing going from one volume and concentration to a different volume and concentration, or I give you grams of that thing and I ask you for concentration of that thing, okay? So when I have a reaction, when I have two different things, then I'm doing solution stoichiometry, okay? So the first thing you want to do here is write out your equation, balanced equation. KCl is combining with lead 2 nitrate to give lead chloride and potassium nitrate, and 3, 2, 2, 2, and 2. Okay, all right. And so here's how I think through this. I have the volume and concentration of lead 2 nitrate. I can figure out the moles because big M equals moles per liter. And so to rearrange this, mole equals molarity times liters. Okay, and so I can take my volume here. I can take my molarity. Moles of PbNO32 would be my volume times my concentration, which gives me 0.02625 moles. Now I can set it up as the stoichiometry that we've done so far. Okay, so 0.02625 moles of lead 2 nitrate. Question's asking me to figure out the volume of KCl given a concentration of KCl. So I know the concentration, I need to find the moles of KCl. And so now I go to the reaction, and 1 mole of lead 2 nitrate, I have 2 moles of KCl in that. And this gives me 0.0525 moles. Technically, you can keep it going if you would like. Actually, sure, why not? And so 0.150 moles per liter is what I have of that, okay? So I have that many moles of KCl, but my volume, big L, is going to equal 0.0525 moles of KCl divided by my concentration. This comes from the question, 0.150 moles per liter of KCl. Moles cancel out, I'm left with volume, which should be 0.350 liters of KCl. Okay, so really the only difference here is we're adding the idea of molarity, KCl, which is moles per liter. Okay, so still dealing with moles, still doing the same stoichiometry, make sure your units cancel out. Yeah, after the moles here, and then we go from there. Okay, and that's that.